Uh, how's everyone doing so far?
Woo! Thank you for asking.
So my name is Mousa AbuGhosh. I'm a grad student at University of Nevada, Reno. I'm working on introducing a new data provider to Parsl, which is called Falcon. So nowadays, there's a wide increase in the transfer optimization. Science applications are becoming increasingly data intensive. It increased from 5 megabytes in 2006 to 5 gigabytes in 2018, and it wasn't linear, it's exponential. So you can imagine how much it grew till like 2023. Most data produced are used for processing, as seen in most of the presentations today, or for archival. And research networks can reach up to 100 gigabytes per second, but none of the transfer protocols actually utilize that capacity. So concurrency usually is the solution for such a thing, but how much is too much concurrency, or how much is enough concurrency? So this is where Falcon comes into play. Falcon is a transfer protocol that's been designed and is maintained today and improved by my lab mate, Mohammed Arif Zaman, my advisor, Engin Arsalan, and currently is also maintained by me. The main objectives of our transfer protocol is low overhead, high performance, and fair resource sharing. So all these objectives have a specific thing that could limit that. So in low overhead, high concurrency can cause overwhelming for the resources that's available for the system. High performance using a fixed or a small concurrency could not actually utilize the system as we want to utilize it. And first, resource sharing, lacking a penalty term could cause poor utilization for resources we have. So Falcon is an online, decentralized, and a black box transfer optimizer. It has two main components, which is the optimization algorithm and utility function. So the online optimizer computes XNO, which tells the network how much throughput we can push and how much concurrency we can push without affecting the system itself. And the utility function makes sure that it processes that feedback in order to maintain the maximum amount of throughput for that. As you can see in this graph, Falcon, there's two Falcons here, which is different utility functions. Falcon in general is 2.2 times faster, has higher throughput than Globus and 55% higher throughput than Harm. So my main topic where I implement Falcon into Parsl, I took two approaches in doing so. The first approach was using the same approach as other data providers, where they use the object file, which is already implemented in Falcon, and just using different message queues. I found ZMQ to be the most successful in that. I use ZMQ to achieve this transfer and in order to send acknowledgement back to the system. This approach required a lot of changes in both Falcon and my part of Parsl, and the results are as shown here. So Falcon performed really well on low number of files, but if they have large, like 10 gigabytes and above. However, the performance degrades really fast. This is, I'm not sure why it's not shown here, but the first one is Falcon, the second one is FTP, and the third one is HTTP. So I resorted to a second approach where I introduced a new class, which is directory instead of file, where you send an entire directory and let Falcon handle the multiprocessing in there. You can use Parsl to send multiple directories, but the parallelism in the directory itself is handled by Falcon itself. So in this approach, as I said, we use the object directory instead of file. it serves the same purpose. It has really close properties. It just lacks the obvious things, file name and so on. And we utilize our package, which is Falcon Data Movers, to achieve this transfer. This approach has higher success here, where you can see Falcon as the first column. It had higher throughput than all other data providers that are currently available on Parsl. It's not shown here as well. So the first one is Falcon, second is FTP, third is HTTP, and the last one is Globus. So this tests were tested on both a local network and a wide network. These are the averages. So in most cases, Falcon does perform better than the other data providers. So in both versions, Falcon Sender, which is a part of Falcon that utilizes the sending process, has to be operating on a sender or like the source host. In version 1, you are required also to run Falcon Receiver on the destination host. However, in version 2, Parsl takes care of that. Version 2 provides a much higher average throughput, as shown in the graphs. But improvements are still happening on this project. It's still an ongoing project. Nothing is set in stone. We're looking for more ways to utilize and optimize this approach. Thank you so much for listening. Any questions?
We have questions from the room. A question from Zoom. There's a question. Is there a list of ports used for transfers?
You can specify the port you want to use. We're currently sticking with one port, but you have the possibility to choosing whatever port you want to use for that. Thank you so much.
Thank you.